In this video, I'll discuss roofs in perspective, and it's all in my book, Ellen's Guide to Drawing Shapes, on Amazon. There are three main triangles. There's equilateral triangle that has three equal sides. There's an isosceles triangle with two equal sides, and an important vertical line here, perpendicular to the base. And then there are right triangles that contain a right angle. An isosceles triangle is typical of a roof because it has two slanting sides, usually with the same pitch. The line from the peak of the roof down to the base forms a right angle and stabilizes the shape. Roofs are inclined planes, and if one face of the house is parallel to the picture plane with true horizontal and vertical lines, here straddling this vertical vanishing line, then the roofs converge toward the same vanishing point. If, however, the house is in two-point perspective, then each roof has its own vanishing point above and below eye level, and the distance above eye level equals the distance below eye level if the roof lines have the same degree of slant. And the more they slant, the further away this vanishing point is from eye level. The problem with this approach is that the roof vanishing points are usually well out of the picture. So we see one here, but the other one is well below the vanishing point for the building. I'll now show you two ways to circumvent the problem of using roof vanishing points that are well out of the picture. In this first one, we have one face of the house parallel to the picture plane, meaning it has true horizontal and vertical lines. Find the center of this front face where the diagonals cross and construct a vertical line, and choose a peak for the roof on that line, and then connect it to both sides of the house, forming an isosceles triangle. Then the roof tops converge toward the same vanishing point as the house. The other way of avoiding these vanishing points for the roof that are far apart is to not use vanishing points at all, but rather to draw the roof as a triangular prism. So find the front triangle, and you can judge it comparing angles to a clock. So this might be something like 5 after 2. Then draw these lines that are either parallel or converging, including the one up here, and then fit in another triangle in the back, touching the same converging lines. And you construct the house underneath this triangular prism. I've complicated this roof by adding an overhang and a view from the side instead of seeing it straight on. The actual side of the house under the overhang is this red isosceles triangle, where the left side is hidden underneath the roof. To find the geometric center of this triangle, draw a line from each apex to the middle of the opposite side. And if you do that 3 times, you'll find the geometric center of the triangle, where this side of the triangle is equal to this side of the triangle. There's only one line that's going to be perpendicular to the base, and that's the one through the apex. But something's wrong with this look. It looks like the roof is at risk of sliding down. So what do? The important line then for this triangle is the perspective line that travels from the apex vertically down to the base. So this vertical relationship provides stability to the dormer, which no longer seems at risk of sliding down. And it travels behind the geometric center of the triangle. And it forms right angles in perspective. So this right angle is small, and this one's a little larger. And as a result, the front edge of this triangle is larger than the back edge. And that's what we expect with perspective. Everything in front should be larger than things in the back. A window helps this image become more understandable. It looks like a parallelogram with no true right angles, although we know, in fact, is a rectangle with perpendicular corners. Its sides are vertical, like the perspective line, and its bottom and top slant with the house. Since this window appears closer to the left than the right side of the roof, we know there's an overhang with part of the triangle hidden underneath right here. The window also helps us find the center of the recessed roof because the perspective line starts at the apex of this triangle and goes down, and usually the part of the window in front of this perspective line is a little bigger than the part in back. We see right triangles everywhere because they connect vertical and horizontal surfaces, like furniture or the house and the terrace. All these right angles are a little wide because we're seeing them from a bird's eye view and they're pointing toward us. The appearance of a right triangle changes depending on whether it's projected toward or away from the viewer. This green one is a real right triangle because it has true horizontal and vertical lines, so this is a true right angle. The blue one with its tip on this ellipse has a wide right angle in perspective, whereas the purple one that points away from us, still with its tip on this ellipse, has a much smaller right angle. While the whole roof can be viewed as an isosceles triangle, it can also be seen as two right triangles put together. And since we're looking up at the roof, the right angles vary, but it's the opposite from this bird's eye view. So when the triangle points toward us, this is less than 90 degrees, whereas this was more than 90 degrees. When the triangle points away from us, the right angle is more than 90 degrees, whereas this one is less than 90 degrees. In my next video, I'll show you how to draw stairs, and please remember to subscribe.